Hi everyone, in this video we will see how a real world optimization, how I led a real world optimization on logistics event processing system. This system was under pressure due to growing data volume and latency requirements. I used event driven design and async patterns to redesign the pipeline. We reduced latency dramatically and scaled the system's throughput substantially. Let's begin with the context in which this challenge arose. Our logistics tracking system was ingesting high frequency GPS and status updates. Each incoming event triggered synchronous writes to PostgreSQL, introducing input-output bottlenecks. At peak load, the system struggled with 2-second latency, unacceptable for real-time tracking. This latency delayed alerts and visibility for customers. It also affected dependent services like ETA predictions and shipment analytics. The business needed an architectural solution that could scale without sacrificing accuracy or consistency. I was tasked with redesigning the pipeline to handle growing data loads. The goal was to achieve sub-second processing latency even during high ingestion bursts. It was critical to preserve the ordering of events within each shipment stream. We also had to ensure no event was lost, even during partial system failures. The solution had to work well within our existing cloud native architecture. Finally, the rewrite needed to be backward compatible with downstream consumers. First, I decoupled ingestion from persistence using Kafka as a backbone. Consumers were redesigned to batch and process events in small chunks. Redis was added as a lightweight in memory write ahead buffer for speed. A background process handled PostgreSQL writes asynchronously, ensuring persistence. We added retry logic with exponential backoff and a dead letter queue to catch failures. Observability was a priority. We integrated open telemetry to track latency and failures. Latency improved drastically, now averaging 250 to 300 milliseconds even at peak. Throughput increased by 4x, handling bursts of incoming data reliably. No data was lost during peak load or under node failures thanks to buffer and retry design. ETA accuracy improved because events arrived faster and in correct order. Teams could debug faster with new tracing, reducing MTTR during outages. The architecture scaled linearly and allowed faster and onboarding of new features. Today, I'd consider Apache Flink or Kafka Streams to better handle event enrichment and windowing. I'd add proper flow control using reactive patterns to prevent overload in downstream consumers. Real-time metrics using Prometheus and Grafana would further improve observability. Using a schema registry would prevent breaking changes when evolving the event structure. Apache Pulsar could be an alternative to Kafka due to its naive multi-tenancy and compaction features. Finally, I would explore using LLMs or anomaly detection systems to flag unusual patterns in delivery events in near real time.